Hello, I am William Kokenauer, and this is my final project for MEMS 31, Intro to Electrical Circuits. So the project goal was to create a circuit to complete a stated task and then complete analysis on that circuit. The circuit that I came up with in the task was to have a handheld hot dog oven. And this would be able to cook a hot dog in a specified amount of time and should notify the user whenever the hot dog is finished cooking and meet all of the design requirements set by the project. So completing this, I came up with two designs, and I'll present them both separately. Beginning, I came up with this design one. It is powered by two AA batteries for a voltage supply of 3.6 volts. The heating elements are modeled using resistors, as you can see on the circuit layout on the left, and it has two cooking modes. And these cooking modes are modified or moved between using the switch in the circuit. The intended runtime for the first cooking mode, which is just cooking the hot dog, is about 10 minutes. And then the second cooking mode, which is searing the hot dog, the runtime is about 30 seconds. So to begin with, I did analysis on this design one. This is where most of my time in analysis and on the project in general went. The major equations I used are seen on the screen here on the left, and the analysis roadmap is on the right. So basically, the way I went through this was, to begin, I researched a little bit in terms of general cooking times for a hot dog and the intended cooking temperatures of hot dogs. So to begin with, I approximated the cooking time, the cooking temperature of the internal heat of a hot dog is the medium heat for pork. And then separately, I did the same thing for a searing temperature for just the casing. And so using equation 2, which is the specific heat, I modeled the specific heat of a hot dog as the specific heat of ham because they're likely very close, and hot dog specific heat is not really generally available. Using the temperatures approximated from the first step and the specific heat and the approximate mass of a hot dog, I calculated the heat required for each of those steps for cooking and for searing. And then for step 3, I took those heats and calculated the current required to achieve that heat through joule heating of the resistor. The resistance here, using Ohm's law, left that as a function of current with the 3.6 volt supply that we have, and then later on calculated the current, or calculated the resistance from that. And then finally, for the final step, using the power equation, equation 4, I just checked to ensure that my resistance and current values were correct to achieve the intended power for the amount of time, and they were both right. So the results we have here, as you can see on the screen, we have the cooking temperatures and the intended runtime and heat delivered. And we achieved all of those with the current, the circuit configurations you can see on the bottom. For design 2, I modified design 1 a bit to meet some of the additional design requirements for the project. I added an LED that would shut off whenever approximately 10 minutes of cook time was reached, and added a capacitor which is used to time the LED. Unfortunately, because of this change, I simplified it to only one cooking mode, and that would just be to cook the hot dog. I completed analysis on this in a bit more of a basic way, just using Fallstad. I modeled it in Fallstad and then analyzed the results, looking at the LED shutoff time and ensuring that current was still running to the resistor, which is being modeled as the heating element. The results I got, unfortunately, were that it had an approximate LED shutoff time of about 2 minutes. So, which was not the goal for cooking time, and that would be a bit undercooked for a nice juicy glizzy. So my suggestions for improvements on this project would be to increase the capacitance. I began with a 20 farad capacitance bringing it up to about 200, I saw a much closer LED shutoff time to what I was looking for. Um, One of the considerations to look at, though, at this point is to ensure that the resistances A and B that you see on the screen here are balanced well. The LED has specifications showing what the required max current and minimum current at which the LED will shut off are, and these have to be balanced to make sure that at the beginning the LED is not above the max current, and then as it runs, you're maximizing that time at which it will shut off and reaching that intended cook time. So yeah, that is my project. Thank you for your time.